Hey guys, welcome back. So what we're looking at today is 6.7 Pythagoras by proportions. So let's go ahead and jump right in. So here we're looking at determining similarity and congruence in triangles. So we want to determine which of the triangles below are similar and which are congruent. Justify your conclusions. Give your reasoning for the triangles you pick to be similar and congruent. So let's start with the congruent. That's a little easier to work through. Remember, in order for them to be congruent, all the sides have to be the same and all the angles have to be the same. So if we look, we've got a lot of different triangles going on here, but this triangle here, triangle B, and triangle G both have arc marks there, a side there, and then another arc over there. So triangle B is congruent to triangle G by angle, side, angle. So angle, side, angle. That's how we take and do it. We start with one and then we go to the closest one. We don't want to skip from here all the way over and go angle, angle, side. We want to go nice and in order. All right, so there we have one congruent triangle marked off. Now, there is one more that's also congruent, and that's going to be our D and H. So notice, tick marks on that side, and a mark on that side, so they are congruent. So triangle D is congruent to triangle H, and we're given all three sides, so it's by side, side, side. All right, now we want to look at similar triangles. So similar means that they have the same angles, but their sides are not the same. So we're looking for those same angles. So notice 3 and 3, one with a line, one with a line. So triangle A is similar to triangle C by angle, angle similarity. Two angles have to be the same in order to show that they are similar. So that being said, we've got 2 here and 1 with that mark. Notice triangle F has the same thing. So triangle E is similar to triangle F by angle, angle. Now, if triangles are congruent, they are also similar. So triangle B is similar to triangle G, and triangle D is similar to triangle H, also by angle, angle. So that will always be the case. If figures are congruent, they are also similar. All right. Use the given right triangles with altitudes drawn to the hypotenuse to correctly complete the proportions. So proportions is your key word for this lesson. So we have A over C, so this side over the whole hypotenuse, is equal to F, which is a side, over, you need the hypotenuse, which would be B of that little triangle. So notice we've got 3 different right triangles going on. One big one that's the whole thing, and then 2 smaller ones that make up it. Now for 7, we have B over C, so B over C, so the short side, over the hypotenuse, equals E, also the short side, over, well, it's going to be B again because we want the hypotenuse. All right, find a missing value for each right triangle with the altitude. So here we're looking at one of the sides. We've got the hypotenuse here, so we can use the Pythagorean theorem. So we've got 5 squared plus x squared equals 8 squared. So 25 plus x squared equals 64. Subtract the 25. So we have x squared equals 64 minus 25 is going to give us 39. Take the square root. So x equals the square root of 39, or approximately 6.2. So now in trying to find this here, we're looking at solving it a little differently. So we're trying to find that altitude. Set up a proportion to solve just like we had above. So we're looking for the long side here, and we have the hypotenuse and we have this hypotenuse, and let's see, hypotenuse, short side. So we're going to take 8 over 6.2 equals 5 over x. So we cross multiply and solve this. So 6.2 times 5 is going to give us 31 divided by 8 will give us x equals 3.875 or approximately 3.9. So that would be the length there for that middle part. All right, same idea over here. So we have proportions that we need to set up. So we'll have 5 over 6 equals 8 over x. So 5 and 6 are from the smaller triangle. We add the 3 and 5 together to get the 8 and put it over the x. So then we cross multiply and solve this, and we're going to get 9.6 for our question mark. Now, when looking at arithmetic and geometric sequences, when we have two terms but nothing in between them, for arithmetic, we use slope. So we take 22 minus 7 over 4 minus 1. 22 minus 7 is 15. Over 4 minus 1 is 3. So we're adding 5 each time. So 7 plus 5 is 12. 12 plus 5 is 17. 17 plus 5 is 22. So for the geometric sequence, here we're going to take the fourth term, 56, and we're going to divide it by 7, which is going to give us 8. And then because there are 2 places missing and the 56 was in the fourth, we're going to take the third root of 8, which is going to give us 2. So 2 is what we're multiplying by. So we take 7 times 2, which is 14, and 14 times 2, which is 28. And then 28 times 2 would give us 56, so it works out. So you'll do the same thing for 14 and 15. 14 is arithmetic, just like 12. 15 is geometric, just like 13. All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.